All right. Like I said, my name is Justin Johnson. I'm the architect here at Seeq, and I'm happy to be talking to you. Later, I'll introduce Don to come up and show you a little bit of a demo, some use cases. So at Seeq, we're a good partner with OSIsoft. We've been doing this for a while. Our first show was in 2015, and we've attended a lot of user conferences since then. And we realized that good OSIsoft customers tend to make good Seeq customers. All right, and our goal at Seeq, I'll show you a little bit about our software. But our goal is to empower users in all roles, from process engineers up and down the corporate hierarchy. Anybody who thinks that there's value in time series data and wants to reveal that value with self-service advanced analytics. All right, Seeq covers a pretty wide swath of capabilities, and I've listed some up there. Root cause analysis, near real-time predictions, and we're really getting to the heart of what's happening with descriptive analytics, to root cause incidents and such. Okay, and we connect to pretty much the entire OSIsoft stack, and there's supposed to be an Excel logo there. So we connect to almost everything. You can see the Pi data archive there, but all the way through to Pi Vision, Pi notifications, and what's not there yet is OCS, and so that's what I'm here to talk to you about today, is OSIsoft's cloud services. Okay, the first thing that I want to say about OCS is just how easy it was to get Seeq connected to it. It took a little bit less than an hour, and connecting, actually doing the connection was a few minutes once I got the credentials from Don, and everything was pretty straightforward. Okay, so the demo I'm going to show you today is roughly this setup. So we've got the Pi system is at Devon Energy, and there's a connector that Don will talk about installed on site there, and that's pumping data up into the OSIsoft Cloud Services platform. And then I've got Seeq running in Azure. I believe that OSIsoft Cloud Services is also running in Azure, but that's kind of a detail. You can put the Seeq server pretty much anywhere, but in this case, it's also running in Azure. And then we're here at PI World, and I'm going to try and do a live demo. Those are always touch and go, but we're here at PI World, and we'll be getting Seeq over HTTPS today. Okay, so let me stop sharing this, move over here, and the first thing I want to show you is OCS. So when you go to cloud.osisoft.com, you're presented with this page. It's in limited availability right now, but I happen to have a login here. Okay, so this is what it looks like when you first log in, and it's pretty well laid out interface, I think. And here you can see they've got API documentation integrated right in that you can click through and see how to actually access your data. And then I won't get too technical here, but they've also got an API console so that you can issue REST queries and get the results back, so you can develop and see how to connect with this on kind of a lower level. It's pretty straightforward, pretty modern, I would say. And so we use this interface and the API documentation to develop a connector in Seeq, and it's one of the many connectors, as I showed you, we connect to the wide swath of OSIsoft products and a lot of data sources, and this is a new one for us that's also in limited availability right now. And that's connected to Seeq. And so here I've logged into the Seeq instance that's running up in Azure. And here we can see that OSIsoft Cloud Services is one of the data sources that we connect to. And in this case, we're connected to 6 total, a Pi server there, an AF server, and OSIsoft Cloud Services. And there's some 6,000 items indexed off of that. Okay, and when you first log into Seeq, this is what you see, and this is a list of workbooks, we call them. And here I've created one, PI World, and I'll go and open this worksheet, which is one of these views over here on the side. And I want to give you just kind of an overview of this is what the Seeq application is, so that when Don does his use cases, it'll make a little bit more sense to you on kind of what you're seeing. So over here on the left, like I said, you've got these worksheets that Don will flip through, and then here's your data tab, where you can see these are the asset trees that we've sunk in. One of them here is coming from OCS, and one's coming from Asset Framework. There's example data. There's quite a few different data sources that there are places that you can get framework data from. Okay, and here if I plot a couple of these signals, just sort of clicking down, I guess that one doesn't have data for it. When I made that fetch, that data actually came from OCS. So it's not being stored in Seeq. That data is staying there in OCS, just like it stays in Pi when we connect to Pi. And so when I requested this, I guess 10.7 days of data, we went to OCS, grabbed that data, and brought it back, displayed it on your screen. And when I scroll around, that same thing is happening there. And just for a little bit of context here, here's some tools. We've got about 30 tools that we've built user interfaces for, but we have a formula language that allows you, with some 350 functions, somewhat similar to Excel, that allows you to do deeper analytics if you want to. But I wanted to show you just one real quick, which is our profile search. And so this will allow you to select an area on a trend, specify what similarity you want. Let's do maybe 95%. Select what signal you want to search on here. Let's do that purple one. And it'll go out and find, here it's found that, of course, the area that I just selected is a match, and then this area over here visually looks somewhat similar. And so that's just a way of getting this capsule data, this context data in. And then once you've got capsules, you can do things like totalize area under the curve of that, turn that totalization every time there's one of these capsules into another signal. You can start doing even just simple statistics here, like down here, I've got this other signal, and I want to find the minimum and average of that other signal while we're in these capsules, and I want to sort these capsules by the duration, let's say. So I've got kind of a little table down here that allows me to get a rapid kind of overview of what it is that I'm looking at. And I'll let Don take it, show you a little bit more about what you can do with Seeq when it's connected to OCS or Pi, and he's got a few use cases for you. So with that, let me just recap of what we just looked at, and then I'll introduce Don. So again, that was Devon data up in OCS, connected to the Devon Energy Pi system, and streaming data up to OCS, funneled through Seeq for some analytics and visualization capabilities, and then back down to us here, and it thankfully worked in a demo environment. And hopefully it'll continue working while Don shows you the rest of the use cases. Okay, Don, you want to come up here and show them the rest?
Okay, thanks, Dustin. Okay, so I'm Don Morrison from Devon Energy. We're based in Oklahoma City, Oklahoma. We've got assets in Canada, the Northern Rockies, Texas, and then kind of our core areas in western Oklahoma and southeastern New Mexico. We've been really kind of pushing, like everybody else, to use technology in a way that we can actually impact our business. We don't claim to have gotten all this right yet, but that's the goal. So a little bit about our system. We've got a Pi system that's got quite a few collectives, roughly about 6.5 million tags at this point. And we're taking all that data from the SCADA system that you see here on the left with the red. We want to move that through Pi. We'll use Pi to do some model normalization, get things as standardized as we can, do some data quality if possible, and then move that off into tools that the users are going to be using. So kind of your typical goals there. One thing we do a lot of is share data with third parties. So we may have vendors or service providers on sites that need to get some of the data that we're already collecting. That is difficult in the past, and we fight with firewalls. So death by firewall, if anybody has tried to do this and set up VPNs and things and ask IT to punch holes in your firewall so you can get that data connected, it's not a fun experience, it takes a long time, and nobody likes it. So we've got our PI system here on the left, our data archives. We've got some AFs that are attached to that data to give it context. User tools there in the kind of middle next to the firewall, and then all our vendors that need the data. So this has been hard in the past. So OCS, at least in our experience for this kind of beta that we've been a part of, we can install an agent on one of our servers inside of our network. It manages getting data and taking requests from the cloud, getting that data and pushing it up to the OSIsoft cloud service layer. That doesn't require any firewall modifications at all, since that's an outbound connection to the cloud. And then those vendors can all connect to OCS, and then we can administer OCS and provide client credentials for the different applications that they want to come use or the data that we want them to have. We also have good control over what data they have access to, and we can revoke that access at any time. In the past, in order to do this, especially if we were able to maybe succeed in getting through the firewall and getting people connected to some data, we'd have to issue a contractor account. IT'd be managing that account. We'd need to manage, password refreshes and all that stuff that goes with having extra users that aren't actual employees in your IT system. That's no fun. So I've got a few slides here just to show you kind of the user experience on my side of setting this up within Devon. And it was a pretty easy experience. So there's been a couple demos too, so you guys have seen a bunch of these screens already. So we'll go through these pretty quick. So here's the menu, as Dustin just showed you. Pretty intuitive. The data services piece is kind of where I'll show you quite a bit of stuff, and then a little bit on the clients in the security area. So you'd set up a namespace to start. It's kind of like setting up distinct buckets that you want to put data into in the cloud. So we set up a namespace, and then we'll set up a connection, and this lets us basically tell OCS, hey, we're going to connect an agent to you. As part of that, it'll give you a downloadable installer that has the installer that you would go and put on your PI server or another server within your environment. Once that connects, you see right here on the right where it says PI system, that's the server that has now connected to OCS. And then you go through what's called a point transfer. So you set up a transfer. It's basically a string search through your tags. You give it some kind of wildcard search, and then hit run query. It'll return all the stuff from that agent that it can find, and then you can define what kind of historical time period you want to backfill, which is very easy to do. Click Add Transfer, and then you'll have your transfer set up here on the right, and you can start that. You can also see the things that you've done in this notification area if there's anything important. And then you can monitor the status of that transfer. So this one actually completed, and then now it's currently, if you see current activity there, I don't know how to make it, that's okay. If you see current activity there on the kind of right center, it says it's sending streaming data. So it's now updating data kind of live as the PI server gets new data. This works really well. Here's the sequential data store. So SDS, this is actually basically the equivalent of what you would call an archive on your on-prem instance of PI. And PI points in here are called streams. So here you can search through those and get current values, et cetera. Or you could go use the API console that Dustin had showed you to get more data. A little bit about clients. Whenever we decided we were going to let Seeq come in and get some of this data, I came in here and added a new client, and then I gave Dustin the client ID, a secret, and our tenant ID, and he's able to connect at that point. We can see the status of that connection, and we can revoke it if we so choose that we don't like Dustin anymore, which is great. So I've got a few business examples for you that I'll walk you through just to kind of show you using OCS in the cloud with Seeq, and some things that we've done within our company, just mostly in training sessions and things like that to kind of show the value of the tool set to business users. Okay, so the first one I've got is on electric submersible pumps. ESPs, for those that aren't familiar, are basically motors that get installed, motor pumps that get installed down inside the wellbore, and then they pump fluid up the wellbore. You can move a lot of fluid that way. The problem with ESPs is they're very, very expensive. They're hard to maintain, and they're expensive to maintain. So one thing we want to prevent is that motor starting and stopping a lot. And so if you have certain days where things are going wrong, that motor starts to run, it doesn't run for very long, and then it stops. Those cycles cause a lot of wear on the pump, and so we want to reduce that occurrence. So here's a PI Vision screen showing some of the data that we're going to look at here. The blue line here is the frequency. The orange line is amperage on the motor. And so I've got a quick demo here that will basically show us trying to detect these little dips where this thing is turned off. And then we want to kind of summarize some stuff about that. So we'll do that now. Okay, so here we are in Seeq. And we're already kind of in our asset tree right here. And so we're going to search for that same well, which was this CDU 161. And we're going to come in here and put the frequency is really the only one that we need. So we have our signal here for the time period that we're interested in. So the first thing we're going to do is basically just identify when these things are off. So you're going to have some user that is very knowledgeable about this process, about this equipment, that's going to come in here and do this. And we found that that's ideal because they know their data set, they know their data, and they can kind of iterate through these solutions very quickly. Where if they have me go in there, I don't know a whole lot about their stuff, and we'll go through this kind of iterative process week after week after week. This way they can sit here for 2 minutes and figure out what they want to do, or 2 hours, or however long it takes them. So one thing we know as an expert in ESPs is that they can't really run below about 40 or 45 hertz, so we're going to put a value search in here. We'll call it ESP off. And then we'll pick frequency because that's the signal we want to analyze. And we will do kind of a simple filter on this. And anytime that it's less than, we'll just say 25 because it's in the middle. And then we'll execute that. So Seeq has gone ahead and found the 2 instances here. This isn't very exciting yet. There's not just a ton of data on the screen. But what we want to do is we want to know how many of these actually occur in any given day. So how many times does the ESP shut off and come back on in any given day? And so to do that, we need to add days kind of as a bounding period. So we'll add this periodic condition right here because we want to summarize over days. And we'll just pick daily. And we will turn that on. And now we're going to basically make a new signal. So I want to count how many times that happened over every day. So we can do this signal from condition, which is kind of neat. You can create a lot of data in here. And this is going to be called cycles. So we'll pick our ESP off condition that we just created, because that's the thing we want to count. We want to count how many times that occurred, and we're going to count them. And then our bounding condition is our days, so we want to count over days. And we'll just put the start time, or the timestamp at the start to kind of report it as midnight of that day. We can hit execute, and now we've got a spot here where we're counting these events occurring during those days. And so if we were to select one of these, we can see that even though this is a long blue line, it's really the days and their end-to-end capsules that encompass each day. So now we've kind of created like the basic analysis that we were interested in making, but we want to go look at some other assets. And so you might have an operator that wants to, or a well analyst that wants to kind of review his wells to look for these kind of anomalies. And we can do that by kind of using an asset swap. And so we'll back up out into the wells here, and we'll go look at maybe another well that we think is interesting. This ARC36, we'll swap it with the current asset that's on the screen. It'll go and pull data for that and run analysis on that particular asset, and now we can see that this particular one has actually had some issues early in the month and late in the month. We're looking at about 20 days right now. So we can see down here that these counters are, we've got one here that's at 5. So like that day it actually cycled 5 times. The day before that it cycled 4 times. These are things that we want to know about so that we could go and investigate further and try to prevent that ESP from starting over and over again. So that's the demo I've got on ESP cycles. You could take this a lot further. Probably the next step would probably be to say, hey, Seeq, tell me across all of these assets how many of these actually have this condition occurring. We don't have time to do that one today, but that would be a great use case. And I think that'd be the logical next step. Okay, so next demo I've got for you, just to kind of set it up, is well completion. So well stimulation operations occur after the drilling of the well. So drilling rig will come in, drill a hole in the ground. A crew will come in behind them that does stimulation. They'll hook up all these pipes to the wellhead. It looks like a total mess, and they will pump fluid down into the wellbore. That's called the slurry rate. So they measure that in barrels per minute. And then there's also a treating pressure that we will monitor. So those are really the two key things that we want to monitor. There's a bunch of other data we want. Sometimes we don't get all of it, but these are two things that we typically will get all the time. And really the goal here is to make these little kind of fissures in the rock long and a whole lot of them so that we can collect as much oil and gas from that reservoir as possible over the life of the well. So the two signals I talked about, treating pressure, slurry rate here, what we're really interested in is when we're actually pumping. So we'll use the data from those to actually determine when that's occurring. And then we can do some statistics or create some other value during those time spans that we're really interested in. Or you could do something like just detect these pressure spikes that are occurring here. Those are pressure tests to make sure all the piping and everything is secure. Okay, so another quick demo. All right, so well stimulation. Okay, so like I said, we wanted to search for treating pressure, so I kind of already had this preloaded for treating pressure here. We're going to look at skid number 24. And then we also want to get the slurry rate. So the treating pressure is going to be in PSI, and then the slurry rate will be barrels per minute. Oh, I didn't click on it, did I? Skid 24. Okay, so like I said, we wanted to detect just really when this operation is occurring, when both of these are high. So the first thing we'll do is a value search, kind of like previously, and we're looking for slurry rate to be greater than 2 barrels per minute. So we'll pick slurry rate as our signal. We are going to be when this is greater than 2. We'll execute that. And we'll see that it is doing what we want during these periods of time, and there's some other cases where we have slurry rate that's higher than when we're not pumping, and that's fine, that's expected. But we also want the treating pressure to be greater than about 2,000 psi. And so we'll pick treating pressure for this one. We'll do greater than 2,000. We'll go ahead and execute that one. And so now it will return some cases where just treating pressure is above 2,000. You can see that both of them are present, both those conditions are present during the operation we're interested in, so that's good. And now we want to kind of combine those two things that we just created to get only when both of those are actually active. So we'll do this composite condition. This is going to be called pumping, because this is when our pumps are on and we're actually sending fluid down the wellbore. The first one will be that slurry rate one, then we'll have the treating pressure one, and the condition or logic we want to use here is an intersection, so both conditions must be present. So we're going to AND those together. And then we've got just the things we're interested in. And so to kind of make that a little easier to see, we can just kind of highlight the pumping up here. Oh, I didn't actually mean to do that, so I can just go back, and it will help me not be zoomed in. Perfect. So now we've identified these cases where we've got the conditions that we like, and now we could do things like report on the duration, or I guess I'm zoomed in maybe. Oh, that's what happened. Yeah, okay. Sorry, folks. All right, so duration there, we could add that, and we might want to know like the average of, say, the slurry rate. Like Dustin was showing earlier, we could get averages or durations here. So one of the things that we really need is the total amount of fluid that we put down the wellbore, because we pay for fluid like that, how much they used, etc. and we want to know how much we put in there also so that we can recover all of that liquid at the end of the job. So we didn't actually get that part of the data set in this data stream. We don't have the total volume that they got pumped down, but we do have a rate that they were pumping at, and we know it's in barrels per minute, so we could convert that to a volume. The math we'd use there would be an integral of some kind, and so we can actually do that in Seeq pretty easily, which is pretty awesome. This formula right here helps us do that. And what we're interested in using is where was it? Right here, the slurry rate. So it is D. And you can name these. So like if you wanted to name this, rate, you could do that too, which is actually probably good practice. So we could do rate dot integral. It will help us with that. If we want to know more about that function, I think, is it F1? We can hit F1 and it will actually pull up that information for us, so we can actually see how would we actually use this if we wanted to feel like we were writing code. This is real powerful, and you can do a lot. So we'll go ahead and execute that, and what did I do? Oh, I have to give it a signal. This should actually be the capsule, so if we look over here, I've done it wrong. All right, well, so I did it wrong, so I will just show you this, and then I can show you what I did here. Oh, well, I did the wrong demo. Sorry, guys. That's my fault. Okay, so what we actually wanted to do was count, we could do an integral there, and we could actually show the line. I meant to do the signal from condition here. So what we did was, we're taking the integral still here, but we're doing it over that slurry rate, and then we're using totalized, so what we're doing here is basically taking the integral just during this capsule. We could have done this with code too, and I usually do it with code, and that's probably why I messed that up. So we basically set this up, and we say we're going to use the pumping that we had to take care of those, and then we're going to put the timestamp in the middle. So I don't know why that disappeared, but we go back. Live demos, guys. Don't do them while you're nervous, huh? Okay, well, so the point is in there, and once we had those, well, actually I can just get straight to it, sorry. Okay, cool, this is what I meant to create. So actually this is a good time to point out this kind of journal over here. You can save steps that you've done in here, and so if you're in a meeting and you're like describing what you've done, you can sort of lay out what you meant to say, and then just have like little links to the things that you wanted to do. So like we could actually kill all these data, we get right back to it. It's really, really powerful, and is very helpful when you're trying to show people stuff and you forget what you're doing. Okay, so now we have the clean total here, and that looks good. All right, so we'll go to the last demo that I've got for you, and it is for hauling detection. We've got about 15 minutes, so this one's short, so we've got some time. So hauling detection, when we get oil into all these tanks, on these batteries, all these locations in remote sites, we need to call in a hauling truck. We usually don't have pipeline for oil there. We'll call in a hauling truck, and they will come and connect up to these tanks that you see on the right and offload oil. And there's about 180 barrels that fit in each one of those tanks, and so we have to kind of manage how many trucks we need to send, when we need to send them, et cetera. So what we do is we can measure the total volume in those batteries and all of those tanks, and then we can detect when fluid is flowing out of those tanks. So here you can see this seems fairly straightforward. We just want to detect where these things are moving. And so we will do a demo there. Okay, so for oil hauling, we want this Bednor's 836. So we can see here that we've got kind of a similar signal to what we saw in PiVision a second ago, and we want to detect when these things are coming down like that. So the easiest way I can think to do this would be to just basically take the rate of this and figure out when it's negative. That's really easy to do in Seeq, and this is the one I should have used the formula on. So this will be our flow rate. And we're going to take the derivative this time. Apparently I've done this one before. Okay, so flow rate now, we see this new signal that we created. We have these nice spots that look like we've got negative rate, which is what we expect at these times. And so now we'll just use a simple value search to determine when those are actually negative. So this will be flow out. And you can be as descriptive as you want on these OCD. So we're going to pick our volume that the rate that we just created, the flow rate. And we just want to know when that's negative. So anytime that it's less than 0. So we'll run that. So we see that we did capture the things that we're interested in, but there's some bits out here where it's below 0 for some reason while we're actually filling the tank. And these are real short duration events. That could be because of the way we collect data. It could be a data cleansing issue. There's lots of things that could be. So this is not quite what we wanted to create. So one nice thing, we can just go in here and we can edit this. We can give it a few more bounding conditions and say, maybe this needs to last at least 25 minutes before we'd consider it a hauling event. Or you could use much better logic if you wanted to for the purposes of what we're doing here. We'll try this. And then we see we kind of get what we want. So it cleared up the things that we want to see there. So now the thing we want to do is actually figure out, we've got the start and stop time of these hauling events, and that's good information. But we may want to know how much volume did they actually take, and then we can maybe line those up against maybe the tickets that the vendor on site's turning in, and we could start to almost audit what our vendors are sending in and attach actual SCADA data to maybe a vendor PO or bill, which would be great if we're capable of doing that. So let's see if we can come up with that. So we've got our capsules here, and we want to get the volume. So to do that, we'll do signal from condition again. This is going to be our loads. We will use the volume that we've got there. The statistic that we want, and the one I like the most, is range, because range will take the start time and the stop time, the period in between that. It'll find the maximum value of that signal and the minimum, and then take the difference of those. And our bounding condition is our condition where we're actually flowing out of the tank. And we'll just drop these in the middle. And we can execute that. Okay, and so we can see now that we've added this kind of new signal here that's got some data in it for how much volume was taken during each of these. I told you before that these oil hauling trucks carry about 180 barrels of fluid, and you can see these are between 175 and 184, so 183 here. So this looks like this is working. This is doing kind of what we expected it to do, and we're actually able to get that data off of there. We could also, grab here. We could move this around if we wanted to go get more data or look at different periods in time, and it'll rerun those analyses. Okay, so that is the demo I had for that, and let's see what. And that's it. So your torture is over. So I guess we'll do questions now, and Dustin, if you want to come back up, we can take questions. We've got about 10 minutes.
Yes, thank you. A few notes before we actually do take question. Since we're recording this session, please wait for the microphone. CJ is there in the middle, so you can raise your hand if you have any question. Wait for the microphone, state your name and company, and then ask the question.
Hi there, Yenke Engelbrecht from BHP. Just a quick question, it's probably a bit more technical on the tool itself. Can you put two trends on top of each other with different timelines? So let's say I want to look at the pump's behavior last Tuesday compared to this Tuesday. Can you slide them on top of each other and then also do those events?
Sure, let's give that a shot here. So let's pick out a good signal here. Actually, maybe these ones. So before Don got up and showed how to use Seeq and OCS for his use cases, I did this, where I searched for other pieces of this trend that looked like this, and it found this one over here. And let's say that we're skeptical. You know, it's how similar are they really? So here I can go and I can move into capsule time, and that'll overlay those trends on top of each other. So that was we just have two capsules here, so it overlaid two. But if you've got 20, 30, it'll overlay all of them, and you can get a visual idea of how those events compare. And you can see here the relative timeline starts at 0 hours and then moves for the duration of the time.
Hi. So it seems like there's a lot of really great ad hoc trending functionality and analysis within Seeq. Are you guys doing anything to bring that information back into the PI system once the analytics are run within Seeq?
We have a few use cases where we are doing that, and to do that, we're using the Seeq API layer, just making REST calls to their API, pulling information off of the particular conditions that we've set, the formulas that we've created in Seeq, and then writing those back into PI either on a batch schedule or like from a Windows service of some kind that's running all the time.
Yeah, and I'm showing here just integrated right into our display, actually similar to OCS's control panel. You can see the API reference, and it's a live reference. So here we've got the list of all the endpoints that we support, and you can come in here and you can see the documentation for what all the fields are, whether they're required or optional, and then you can hit try it out, and that executes it, and you can see the result. That's pretty powerful for ad hoc integrations to Python or feeding data back into other systems like OSIsoft PI, but also using it for your analytics. You want it in R or MATLAB, and we have SDKs for Python, C#, Java, and MATLAB.
Good morning. My name is Vinod Nair. I'm from Phillips 66. Don, great presentation. So you mentioned that how you are sending the data to the cloud, OSI cloud, and you mentioned that you don't have to punch through any firewalls. So is it assumption that your PI system is in the business network, or is it behind some other firewalls in 3.5 DMZ or anything like that?
Yeah, so from a kind of topology standpoint, our PI system is our enterprise historian, so it actually sits in an area where the business can access it. So it's not like in our control network, right?
Okay, my question is, what is your recommendation about sending back data to PI? Is using your Seeq API or the AF connector that is also available in Seeq?
Yes, I think you're talking about the AF data reference piece that we have, right?
Yes.
Yes. It's really up to you. So the AF data reference will how that works is you install a small piece into Asset Framework, and that allows you to expose an element that is actually backed by data in Seeq. So when you access that in Asset Framework, that will go out to Seeq and grab that data at that time. If you want to write that data back into PI and have it actually stored in Pi, whether or not Seeq is connected or online, then you could use the SDK to write that data a little bit more indelibly.